Today we're going to talk about the simplest procedure to make deionized water. And it just so happens that this procedure is the same that is used to make clear ice for alcoholic beverages. All you need are one of these metal insulated cups that allows the water to freeze starting from the top. And as the water freezes, it's going to push all of the ions down. So that's why you're going to be left with the top portion of clear ice and the bottom portion of cloudy. So what you do is you fill this cup up with water and you let it freeze. And then the next day you just have to take it out of the fridge and let it thaw. And then you can pour out the top piece of clear ice. As you see here, you shouldn't see any cloudiness in this ice. And then this ice you just have to let melt. And once you let this ice melt, that's your deionized water. So I can prove to you that the melted portion is deionized and the unmelted portion is ionized. It's going. So to prove to you that I made ionized and deionized water using the freezing process, I have the ionized water from the bottom of the container here on the left and the deionized water from the melted clear ice here on the right. And to prove to you that the left is ionized and the right is deionized, I'm going to power up my lab bench power supply to 108 volts. And I'm going to take this platinum positive electrode and this standard copper anode, and I'm going to put them into this water. And as you see, we have about 10 watts being dissipated with 0.1 amps of current flowing. And if I move these closer together, we see more power is being dissipated, and further apart, we see less power is being dissipated. So there's clearly a large amount of current flowing. And what you can't see from the camera is that there's bubbles forming due to the electrolysis process, where oxygen is being formed on this positive electrode and hydrogen is being formed on this negative electrode. So if I take these same two electrodes and I put them in deionized water, you see no current flow. Nothing is being registered. So we have 108 volts in this water, and there's no current flowing, no matter if I put them close together or farther apart, doesn't matter. And I don't want to get these too close because then there might be a spark flying, especially at 108 volts. So we're just going to leave it at that. So I hope you learned that you can use the freezing process to create ionized and deionized water, and this can be used both for scientific purposes and for enjoyment. You can make clear ice to put in your drinks at parties, and you can also use that same clear ice as deionized water in a potential home chemistry project, or even if you just want to fill up a used car battery.